Hello, so in today's video, we're going to discuss what the number E is, this number E. So you may have seen this number E on your calculator, this letter E. You may have heard of this number E before. You may have seen maybe exam papers involving this E, or maybe seen your brothers and sisters do hard maths involving this letter E. So what actually is this number E, and why is it important? So it's a very important number. It's a very important thing that if you continue your education in maths, you will need this number a lot. So why is it? What is it, and why is it important? So let's just do a little recap from yesterday's video. So the video that I did yesterday on sketching the graph y equals a to the power of x. So remember that if a is bigger than 1, then the graph looks something like this exponential graph here. And we call these exponential functions or exponential graphs. So exponential graphs because we can see they're exponentially growing. And remember, when a was between 0 and 1, so if a was between 0 and 1, you got an exponentially decaying curve like this. So you've got an exponential decay there when a was a number between 0 and 1. So now let's think about this graph y equals e to the power of x. So this number e, I mean, it's about 2.7182818 and so on and so on. You can put it in your calculator. Depending on what calculator you have, sometimes you just put, the number e in. On my one, what I've got to do is I have to press shift and then this like LN button, and then I get an E. And then what you can just do if you get this on your calculator, like an E and then a power symbol, you just put 1 there. So e to the power 1 is just E itself. And then, yeah, you get this number here, 2.7182818, and so on and so on and so on. So that's what E is roughly about. It's an irrational number as well. Just make it clear that this is an irrational number. So you can't write it as a fraction as a fraction of 2 positive integers. It is an irrational number. So as expected, E is E is a bigger number than 1, E is greater than 1. So you get this exponential curve here going through 1 there, because remember, when you substitute x equals 0 into this, e to the power of 0 is going to be 1, because, yeah, 2.7 to the power of 0, any number to the power of 0 apart from 0 is equal to 1. So you do get this exponentially growing graph here. So why is this graph so important? Why is this number so important? So let's just talk about, firstly, where this number actually comes from. So where does E come from? So you can get this number E by doing this sum here. So if you do 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial plus 1 over 6 factorial plus 1 over 7 factorial, and so on and so on and so on up to infinity, you get E. So that's kind of where this number actually comes from. So you can actually write it like this. You can write it using summation notation. So this is the sum of 1 over n factorial, from n starting from 0 up to infinity. So it's an infinite sum. So remember, if you plug in n equals 0, just a fact that we need to remember as well from our Pascal's triangle or our binomial expansion videos is that 0 factorial is just 1. So yeah, you get 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial, and so on and so on and so on and so on, just like this here. So that is actually how you can come up with this number E. So if you actually were to do this sum, you would get this 2.7182818 and so on and so on. So yeah, that's kind of how you can give a definition for this E. You can also give this definition as well. You can also say this. Some people use this definition that E is the limit as n goes to infinity of 1 plus 1 over n to the power of m. So basically, when you keep on plugging in massive n values into this here, so yeah, so 1 plus 1 over basically infinity, all to the power of infinity, you get close to this E value. So that's another way that some people define this E as well. You don't really need to know these definitions of E. Actually, you don't actually need to know them in A-level maths. But I guess it's nice to know where you can actually come up with this number E. So we need to go through 2 important facts about E as well in this video. So what are some important facts about E that you should consider? So the first one here is this one. So let's think about a graph y equals 1 over x. And what I've done here is I've just sketched the graph in black here. So we've got 1 over x there, this kind of reciprocal graph. So what I've done here is I put a number 1 there, I put a number E there, and what I've done is I've basically drawn an area below the graph here between 1 and E. So a little fact is that this area there is equal to 1. So the area between 1 and E on the x-axis under this graph here equals 1. So that's another fact about E that we should bear in mind. So again, the area between 1 and E, so like a base here of E minus 1, under this graph, y equals 1 over x, has an area of 1. So that's an important fact about E that we should bear in mind. And another fact, probably the most important fact, is this one here. So let's think about our y equals e to the power of x graph again. And what I've done here is drawn a tangent line. So a tangent line at x equals 0. So we've got a tangent line here like this. So a very important fact is that this gradient of this tangent line equals 1. So the gradient is equal to 1. So y equals e to the x is the only exponential graph. So e is the only number in this base there. It's the only number that gives you a gradient of 1 when you draw this exponential graph here. So when you draw an exponential graph, so obviously you've got, if I just do like a rough sketch down here, you've got like, for example, 2 to the power of x, you've got e to the power of x, which is going to be a little bit steeper than that, so that's e to the power of x. You've got 3 to the power of x, which is even more steeper, so 3 to the x. So e to the x is the only graph that when you take a tangent at 0 here, the gradient is 1. So that's a very important fact. And in fact, I'm going to go even further. Let's just call this x coordinate there capital X. I'm going to call this capital X there. So another very interesting fact about this E graph is if you draw a tangent here at x equals capital X, so what you get here, obviously your y coordinate is going to be e to the capital X. An interesting fact about this is that your gradient there of this red line, this red tangent, so the gradient there is going to be e to the capital X. So your gradient here is actually equal to the y coordinate. So a very important fact about these e to the power of x graphs is that your y coordinate on the graph at a particular point is equal to the gradient of the tangent. So again, where if you do this with any point you like, I mean, if we call this point down here capital A, so this on the the y-axis there is going to be e to capital A. If you were to do a tangent at this point and to calculate the gradient here at A is going to be equal to e to the power of A, which is equal to the y coordinate. So a very important fact that we're going to use throughout maths is that when you take the gradient at a particular point of this y equals e to the power of x graph, you actually get the y coordinate itself. So it does. So this is the only number that it works for. There's no other number this works for. So 2 to the x, this fact doesn't work. 3 to the x, it doesn't work. 10 to the x, it doesn't work. E to the x, this fact does work. So when you take the gradient at any point, do a tangent, take the gradient of that tangent, that gradient will be exactly equal to the y coordinate at that point you looked at. So I've just kind of summarized it here. So the only value of a where a to the power of x is exactly equal to its gradient is e. So what we can therefore say is that e to the power of x is equal to the gradient of y equals e to the power of x at x. So that's kind of what I'm trying to say here. The gradients of these tangents at these particular x coordinates are equal to the y values at those x coordinates. So again, it's the only value here that this works for. So 2 doesn't work, 3 doesn't work, 5 doesn't work, e works. E is the only number that works for, and we're going to use that fact a lot in the rest of A-level maths. So yeah, this was just a brief summary of what this E is, how you can define this E, and a couple of very important facts to bear in mind about this number E.